Good evening, everyone. Can you please respond whether my voice is audible? I think video audio is not working. Let me share my screen. Yeah. Good evening, guys. Welcome to VCube Software Solutions for the day 9th. Today we are going to discuss about regression analysis, okay, and its use cases. So with your permission, can you please respond? The screen and audio both are okay for all of you. I hope the video is not working properly. Yeah. Good evening, guys. Let me go to the today's topic. Yeah. Today onwards, we are going to enter into a beautiful technique called regression analysis. First few minutes, I will be discussing about what is machine learning. Earlier in my day 1 session, I have discussed in detail about what is machine learning. So generally speaking, machine learning has been divided into first one is supervised learning. Second one is unsupervised learning. And third one is reinforcement learning. Okay. Now, once again, supervised learning has been classified into regression analysis, regression, and classification. Okay. In my day 1 session, I have discussed about in detail about what is supervised learning, what is unsupervised learning, and reinforcement learning. Okay. Today, my focus is on regression analysis. And tomorrow, I will be discussing about classification. Okay. So with your permission, shall I enter into the topic? Our today's topic is regression analysis. So before going to discuss about regression analysis, first of all, let me discuss about what the supervised learning is. In supervised learning, what we will do is we will consider input data and we'll also consider output data. Okay. Now, input data will be referred as capital X, output data will be referred as small y. Now, we need to find out the relationship between every input features with target variable. Here, we will be using f of x is nothing but algorithm. Okay, for all of you. Now, when y is called as target variable, when the target variable y is numerical data. Okay, once again, I'm repeating. When the target variable is y is numerical data, also called as quantitative data. Then we are going to apply a technique called regression analysis. Okay, this is today's topic. Is it okay for all of you? Once again, I'm repeating. When the target variable is numerical or also called as quantitative, we are going to apply a technique called regression analysis. Okay. On the other hand, when the target variable y is either categorical data, we will also call it as qualitative data. We will be applying technique called classification. This is tomorrow's topic. Okay, for all of you. This is the basic introduction for this topic. So with your permission, so shall I go for regression analysis? So let me define what is regression analysis. The meaning of regression analysis is, the purpose of regression analysis is predicting future. Predicting future from current and historical data. Okay. Now, this historical data is also called as previous data. Okay, for all of you, please kindly respond to me. Are you getting me now? So shall I erase it? Please kindly respond. The screen is filled. Shall I erase it, please? Yeah. Now, let me erase it and go for regression analysis. Okay. Everyone kindly follow me. Now, the basic purpose of regression analysis is predicting. Some people also call it as forecasting, predicting or forecasting future. Okay. From past data, some people also call it as archival data. Some people also call it as historical data. Okay. Now, when the target variable y is numerical, we are going to apply this technique called regression analysis. Okay. Generally, regression analysis has been divided into, first one is a linear regression. Second one is non-linear regression. Okay. First one is linear regression and second one is non-linear regression. Now, how can we classify whether it is linear regression or not? Okay. It is purely depends upon. Now, when we are following the line equation, y equal to mx plus c. Okay. Generally, this equation is called as line equation. Okay. Now, when we follow the line equation, that is called as linear regression. Other than line equation, if you follow anything, that is called as non-linear regression. Basically, we will be using polynomial regression. Okay. Now, once again, linear regression has been divided into, this is our today's topic, simple linear regression and multilinear regression. Okay. All of you getting me? I will be happy if you respond to me properly. Okay. Till now, any questions? Now, with your permission, can I erase it? Erase it to elaborate more about simple linear regression. Now, simple linear regression means we will take one input features and one output features. Okay. In simple linear regression, what we will do is, now I will be taking one input feature x1 and I will be taking target variable y. Okay. Then this kind of regression is called as simple linear regression. Multiple linear regression means here we will be taking more than one input feature, x1, x2, x3, and so on, xn, where the target variable is 1. Multilinear means we will having two or more input features and one output features. Okay. When we have two or more input features, is mapping with one target variable. This we will be, yes, single value. Yes, single value. In simple linear regression, we will be having only single input. And in multiple linear regression, we will be having two or more than input features. That is called as multiple linear regression. Is it okay for all of you? This is what the introduction to what is a linear regression analysis. So with your permission, if everyone is okay, I will be erasing it and I'll go to the topic. Okay. Can I go forward? Yes. Thank you very much. Let me erase it now. Now, from today onwards, while discussing about every topic, what I will do is, first of all, I will discuss mathematics behind it. Okay. Then I will go for studies from it. So, shall I follow this technique? But if the students knows about the mathematics, then you can easily understand the case studies. So with your permission, I will be entering into the today's topic. Is it okay? Now, all the people, can you please respond to me? The screen is okay for all of you? The screen is okay for all of you? Now, I will be increasing the font. The font is okay for all of you, please. The notebook. Now, otherwise I'll increase the font, please. Now, I'm increasing the font. Don't worry, please. Give me time. Okay. Now, what is the basic purpose of regression analysis? Okay. Basic purpose of regression analysis to answer these questions. My first one is there any relationship between two variables. And if you have the relationship between two variables, we need to find out how strong the relationship is. Then another point we must answer is which variable is contributed most. Okay, that's points we need to answer it. So with your permission, I will be going. Now, whenever you are discussing about linear regression, now, first of all, earlier in your childhood, you studied about y equal to mx plus c. Now, the same equation I have represented as y equal to beta naught plus beta 1 x. Okay. Now, if you have one input variable and one target variable, this is called as simple linear regression. Once again, I'm repeating. If you have one input variable, and one output variable, this is called as simple linear regression. Okay, now here we need to find out the parameter values for beta naught and beta 1. Okay, to find out these parameters, we need to minimize the least squared error. Some people also called as sum of squared errors. Can I continue? Now, whenever you are creating any regression model or machine learning model, okay, regression model will be having some error. Error will be calculated as y minus y cap, where y is nothing but actual output and y cap is nothing but predicted output. Okay. Now you are going to get error 0. Now error must be nearly 0. It may not be 0, but we should try to achieve this. Okay. Now everyone please note down one important point. Now, in order to calculate y cap, we need to find out what is beta naught, and everyone please note down this one. Y cap is equal to beta naught plus beta 1 x, where x is input data, where any kind of input data I will be calling, which is called as y prediction. This is called as output data. Okay, it is called as predicted output data. So with your permission, in order to calculate beta naught and beta 1, we should know the formulas. Okay, for all of you. Now, everyone please note down this. In order to calculate beta naught, the formula is equal to, look at here please. First of all, we will calculate beta 1. How the beta 1 will be calculated? Beta 1 will be calculated as xi minus x bar and multiply yi minus y bar. Then this is the summation divided by xi minus x bar whole square. I'll discuss each and every variable in 1 minute. Okay, for all of you. Now, in order to calculate simple linear regression, we will be taking x variable and y variable, and I will be taking 5 observations. Okay, practical I'll show you. Now, first of all, I will be calculating x bar, mean of x, then I will be calculating y bar. Is it okay, Nama? Then we need to subtract every value minus x bar, that is called as x minus x bar. Then we need to subtract every value minus y bar. This is called as y minus y bar. Then you multiply these two values, then sum. You will get a numerator. Then denominator is, you already subtracted these two, x minus x bar whole square. Now that will give me beta 1. Everyone please note down this formula. Once we calculated beta 1, then we can calculate beta naught. This can be done by using y bar minus beta 1 x. Beta 1 just now we have already calculated. Once if you take these two, I will go for a simple exercise and go for practical exercise case study. With your permission, can I go for a little bit case study, please? Now, in 2 minutes, I will be discussing what is the difference between linear regression and multiple linear regression. In simple linear regression, what is happening? This y cap, beta naught and beta 1 are called as coefficients, and we will be having one input features and we will be getting output features. Now, it may be simple linear regression or it may be multiple. It will have some sort of error that is represented as epsilon. For example, let us discuss about multiple linear regression. In multiple linear regression, what will happen? Beta naught is common, and here for every input one, I will be adding beta 1s. For example, if I want to take 3 input features, x1, x2, x3, what is the formula for y cap? Y cap is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Is it okay for all of you? Now, For every input features, I need to calculate beta 1, beta values. So with your permission, I wanted to demonstrate a small example mathematically. Can you please see the screen? Can you please look at here, Ma? Now this X is the input data and Y is the other input data, output data. Now, first of all, I will be calculating X bar. How to calculate X bar? Add all the data divided by 5. Then calculate Y bar. Okay, I hope everyone is okay. How to calculate X bar and Y bar? Then we need to calculate Xi minus X bar. So 95 minus 78. Okay, then 85 minus 78. Though I will be getting the values of Xi minus X bar. Okay, then I need to calculate Yi minus Y bar to calculate beta 1 value. Once if I got Xi minus X bar and Yi minus Y bar, then the denominator value is Xi minus X bar whole square. Okay. Now this is nothing but if you sum all the data, you are going to get denominator value. In order to calculate numerator value of beta 1, Xi minus X bar multiply Yi minus bar. Then you summation of this value. This is 470. Okay. Now what is the formula for beta 1? Beta 1 formula is equal to summation of Xi minus X bar multiply Yi minus Y bar divided by summation of Xi minus X bar whole square. So this value is 470 divided by 730. Now, beta 1 value, we got it as 0.64. Is it okay for all of you? Now, once we calculate beta 1, then how to calculate beta naught? Beta naught is equal to, just now we have seen, Y bar minus beta 1 X bar. Is it okay for all of you? Now, we have calculated beta 1 value as 0.64 and we know X bar value, Y bar value. Now, beta naught value is 24.08. Now, this is the thing we need to calculate. Now, look at here, for all of you. Now, Y cap is equal to, what is my beta naught value? My beta naught value is 27.08 plus. What is my beta 1 value? 0.64. And then X. Now, for any given value of input data, I can predict Y value. This is called as model. I hope it is clear for all of you. Now, X is nothing but you give any input value. You give any input value. Now we can predict output. This equation is called as a linear regression model with a simple linear regression. I will wait for 1 minute. If you have any questions, I will be happy to respond. Now, with your permission, can I go to implement this case study? I hope it is clear for all of you. Please kindly respond. Any questions? I will be happy to answer them, please. So with your permission, can I go? Yes. I hope no one is asking questions. Yes. Sorry, Emma. Sorry. Once again, total mathematics is impossible to teach. You ask me the doubts, I will explain that topic itself. Please. It is very much sorry, Emma, but I will discuss in the case study, Emma. Please. Dhanlakshmi. Okay. Please. I'm very sorry, please. Because I need to go so much. You listen the topic once again, and I'll give you the number. You please call me. I will explain, Emma. Total explanation needs to be done. Sorry, Emma. Please. Now, I wanted to showcase one more important point, Emma. Look at here. Now, look at here. I want everyone to see the screen. Everyone, please see the screen. Now, whenever you're taking original input data and output data, please listen carefully. Whenever we take original input data and output data, on x-axis I am taking x value and y-axis I am taking y value. Now, you people are finding error equal to, look at here, equal to. Now, whenever you draw a line, what is happening? Some points are above the line and some points are below the line. Okay, these are called as errors. Okay, this is called as error. Now, as a data scientist, what you have to do? We have already calculated y cap value. Y cap equal to 26.768. This is beta naught plus beta 1x. Now, you submit all these values to here. You submit all this value. You submit 95. I got 87.94. You submit 85 like this. Now, if I want to draw a scatter plot between x with the predicted values, now all the points are straight line. Okay. Is it okay? Now, whenever you draw a scatter plot with x value and y predicted values, now all the points are on the straight line. This is what we should try. Now, with your permission, Shall I go for case study? Whatever the mathematics I have discussed till now, shall I implement through case study, Amma? With your permission, can you please respond to me? I will be happy if you ask me any questions right now, but I don't need to repeat once again. That is not required, Amma. Okay, Amma? So I will be going. The entire mathematics I'll share you after the class. Okay. Now just give me 1 minute. Now everyone should know that now regression analysis is a concept. Okay. Now, in order to implement this regression analysis, we need a software. So I will be using sklearn. From today onwards, scikit-learn library mainly used for machine learning applications. Okay. So with your permission, I will be using scikit-learn to implement the job. Is it okay for all of you? Now, let me share my screen. Now, the screen is visible for everyone. True values are on the line as true values. Yes, Dhanlakshmi. Okay. Now, let me change the screen. Look at here, please. Now, first of all, I'm importing NumPy. NumPy for used for performing mathematical operation. Then I will be importing. See here, in order to provide linear regression, we will be importing library called sklearn.linear_model. This is the class responsible for the mathematics till now we have implemented. Okay. Now let me import it. Now, if you observe carefully these two data elements, both X and Y, whatever the mathematics I discussed till now, Lakshmi madam, please. Same mathematics I have taken as X and Y. Is it okay? Now, X is my input and Y is my output. So, shall I call this as simple linear regression? Simple linear regression. Okay. Now, whenever we need to discuss about simple linear regression, everyone should know this scatter plot. Look at here, please. Now, this is X and this is Y. And now we are drawing a line here. This point is called as intercept. We will introduce these points in 2 minutes. And this is called as slope. Okay. I will be discussing more and more mathematics in 2 minutes. So with your permission, I know the X value, I know the Y value. Can I implement linear regression, please? Yes. Now let me go one by one. Now, in my discussion of 2 days back, I discussed about numerical Python, NumPy. There I discussed about a function called reshaping the data. Is it okay? Now this is my X data and this is my Y data. Now, take here, I will be, first of all, I will be creating an object of linear regression object. Okay. Whenever you wanted to use this linear regression, first of all, you should create an object. Okay. Now, you need to follow some steps to implement any kind of algorithm. See here, first of all, you need to create an object. Okay. Now, model is an object of linear regression. Then I'm eligible to train the model using the object. Now, the first step is training. How the training will be done? Now, in machine learning, in order to prepare a training the machine, we will use a function called algorithm.fit function. Now, X is input data and Y is output data. This phase is called as training. Look at here. Now, let me, yes. Now, look at here, Amma. Now, whatever we have done is called as a creation of object of the linear regression object. Then we train the machine. Machine learning will take very few seconds to train the data. Is it okay for all of you? The machine has been trained. And look at here, please. You people are going to get two values. The first one is called as intercept, model.intercept. Okay, this value. 26.78. Then you people are also getting one more point called as coefficient. Okay, it is called as coefficient. That is called as slope. Okay, for all of you. Now, once we get both intercept and coefficient, we will be creating a machine learning model. See here, using predict function, we will be testing all the data. Now, I will be getting predicted values. Is it okay for all of you? Now, if you observe these values carefully, previously I have taken an Excel sheet. Look at here. I have created an Excel sheet here. Please observe. It is that. I think it has been deleted. This one. Look at here, Amma. Please look at here. Now, whenever you look at here, this is the values. Whatever the values I have calculated, this one. Then if you draw a scatter plot between x and y, now all the lines are straight line. Okay, I will be discussing about MSc, MBAE, RMSc in few minutes. Okay, now you people are going to get same kind of line. This one. Now these are the new values. Now I need to reshape the given matrix. I need to reshape the given matrix. Then here, please, all of you. Now I will be creating model dot intercept underscore. This is called as beta naught plus model dot coefficient. We already calculated intercept value and coefficient value. Now this is, now you give me any value of x. I will be predicting output data. Okay, for all of you, ma? Please kindly respond to me. Now look at here. Now I will be giving input data, and what is my value? Now my input data is x. I need to spend 78.28. This is called as a simple linear regression. Is it okay for all of you? Everyone can respond, Nama? Whatever the mathematics I have discussed, same mathematics I have implemented with simple linear regression. Now I will wait here for a few minutes. Any questions? I will be happy to respond to you. Okay for all of you? Yeah, thank you very much. So with your permission, if everyone knows about mathematics, shall I take 5 minutes theory to discuss about error messages? Yeah, this is very much important for you to understand. Okay, for all of you, ma? Now, whenever you are calculating any model, first of all, you have to calculate the error called MEAE, stands for mean absolute error. Earlier, we have only calculated error equal to y minus y cap, kadama? Y minus y cap. Y is called as actual output, and y cap is nothing but predicted output. Okay. Now, mean absolute error is equal to summation of mod of y minus y cap. Okay. Now, what is the meaning of this MEAE? Look at here. Now, if you want to understand, now I have already shown one diagram. I have drawn a scatter plot between input data x and output data y. I shown that some points are above the line and some points are below the line. This is called as error. Okay. So what we have to do, we need to get back this point on this line. Okay. Are you getting me? Then we have calculated y cap is equal to beta naught plus beta 1 x. Now we have calculated beta naught value and beta 1 value, and we predicted this value. Okay, for all of you. Now, what is our responsibility? We need to get all these points onto the straight line. To get this, what I have done, I used another metric called mean squared error. MSE stands for mean squared error, is equal to 1 by total number of observations and the summation of y minus y cap whole square. Here, what we are doing, we are squaring the errors. Now, whenever you square this error, this point is on top of this line. This is what we are doing. Okay. Kindly respond to me. This is what we are doing. Now, let us implement the same thing using technique. In order to implement this metrics such as MEAE, RSME, and MSC, we have a library called sklearn.metrics. Now, simply there is a direct function, mean underscore absolute underscore error. Now, y is called as actual output. Y predicted is nothing but predicted output by the model. Why can't we leave those points? No, we can't leave. We can't leave. Every point, Saujanya, every point is very important for you now. Okay. Okay. Now this is MEAE. Now, how to calculate? Now, how to calculate MSC mean squared error? This can be calculated by using matrix dot mean squared error. Now, same actual input and predicted input. Once you got MSC, finally you have to calculate RMSC. Now, RMSC can be calculated by using numpy dot square root function. Now, RMSC values should be, if I want to say whether the model is good or bad, I have to, the first metric is called as RMSC. That value should be nearly 0. Now, when you get RMSC value nearly 0, that model is called as good model. Okay. Clear for all of you? Then another metric everyone should know is called as R square. Now, 2 minutes I'll discuss about R square technique. Okay, now another metric everyone should know is called as R square. Now, how to calculate R square value? R square values can be calculated like this: 1 minus summation of y minus y cap whole square divided by y minus y bar whole square, where Y is nothing but actual output. Sir, once again, slow the MSC formula. I'll show. Yes, I'll show. Look at here. Now, look at here, Amma. MSC or MAE? MSC. See here, this is MSC formula. MSC formula is equal to mean square error equal to 1 by n summation of y minus y cap whole square. Is it okay? Now, whenever we squared the error, what happened? All my points are touching the line. This is what I have done. Is it okay for all of you, Amma? Yes. Now, let me calculate R square value. R square value can be calculated as summation of y minus y cap whole square. Now, y is not nothing but actual output, and y cap is nothing but predicted output, and y bar is nothing but mean of y. And I will be getting R square. Now, R square values must be between 0 to 1. Okay. Now, if you get R square value 1, that is called as good model. Okay. Now, whenever you are having the R square nearly 0, that is called as poor model. For your information, so both RMSE and R square we use it for metrics for regression analysis. With your permission, is it okay, Nama? Both RMSE and R square can be called as metrics for regression analysis. So let me here. Now, how to use R square metric? Metrics dot R2 underscore score. Now I will get R square value. See here, Amma? See here. I think let me run all the cells. You will get everything. Look at here. Now let me print the values. See here. Look at here, please. R square value is 0.48. For this given data, it is just average result. But you in realistic applications, what you have to do? RMSE value should be nearly 0. Okay. This is one metric. Another metric is R square value should be nearly 1. Okay. If both are satisfied, we can call it as good model. So with your permission, can we apply this mathematics on real-time case studies? That will be useful for your internship purpose. This is what is just introduction to regression analysis. Okay, for all of you, Amma? Please kindly respond to me. Okay, for all of you? Now, with your permission, I wanted to go for beautiful case studies. Now, using these case studies, you can start your internship. Okay. Now, let me go to next case study. Yeah. Next 1 hour, I will be spending on regression analysis case studies. Can I go forward, Amma? Yeah. First of all, I will be showcase the database, then I'll go for case study. Can you please look at here? This is what is called as mathematics and introduction for regression analysis. Now, first of all, I will be showing which database I'm using here. House price prediction. Yes, look at here. Yes, I will be taking house price prediction data set. See here. Very simple data set I have taken for your understanding purpose. First of all, see here. Now, if I want to buy a house, if you people also, if you want to buy a house, first what you will do? First of all, what you will do? First of all, you should identify how much square feet is. Can you respond to me? Now, first of all, you should identify how much square feet is. Then you should ask what is the price. So I will be taking the first case study as simple linear regression. So I will be taking area of a house, then I will be taking price of the house. So shall I call this as simple linear regression? Okay. So shall I start case study? Please kindly respond to me. Yes. Now, go simple to complex case studies one by one. Okay, Nama? Yeah. Now, while executing, if you find any difficulty, please ask me. I will repeat once again. Now, first one is pandas for data analysis, NumPy for numerical applications, and Matplotlib and Seaborn are used for data visualization. Okay, for all of you? Then, first of all, let me import it. I'll go very slow, Amma. First few minutes. Now, I will be reading the data from pandas object.read underscore CSV. Now, I will be reading the data from houseprice.csv. Increase the font. Still? Archu? Still is okay, Nama? Yes. Now, let me go forward. Now, I have read the data from CSV file to a database. Now, house underscore data is my database. Now, let me show you this data set. Look at here. Totally, people are having 1,459 rows and 2 columns. Is it okay for all of you? Totally, we have 1,459 rows and 2 columns. Okay. Now, let me go. First of all, I'm asking the shape of the data. See here, it will give me total data set is 1,459 rows and 2 columns. Then, next, if I want to know the first few records, we will take head function. Head function will give you first 5 records. Then, if you want to know the column names, see here, you can use an attribute called as columns. In my database, I have 2 attributes. First one is area and second one is sale price. Clear for all of you, ma? First one is area and second one is sale price. Now, if you want to study the nature of the data, you can go for histogram. See here, if you go for histogram, what it is doing? Yeah, actually speaking, this technique is called as a normal curve. Okay. Now, still, this data has some. This is actually I cannot go to statistics. Okay, actually, this is not. This is called as normal curve. Okay, for all of you, ma? Okay, but this normal curve is not in the proper position. So most of the data at left side and tail will be at right side. This is called as a positive skewness. Yes, histograms are univariate only. Use univariate only. Did you see the topic, Varshini? Used only area. Is it called as univariate analysis, Amma? Varshini? Yes, histogram is used for univariate analysis. So don't say, please. I am here to teach, please. Okay. Yes. Now I will be showcasing salary also. Yes. Here, most of the data in realistic applications, please listen carefully. In realistic application, most of the data is not in the normal curve. It may be positive skewness, it may be negative skewness. Okay. Yesterday, in data pre-processing techniques, I discussed about log transformation. Now, if you apply log transformation, your positive skewness will be converted into regular job. Okay, that I'm not discussing right now. Okay, now let us use scatter plot. Now, whenever you are going for regression analysis, first of all, you should draw a scatter plot. Now, what the scatter plot will do? On the x-axis, I am taking area, and on the y-axis, I'm taking sale price. Scatter plot is used for multivariate analysis. Here, it will tell you whether the relationship is positive or negative. Can you please look at the screen, Amma? Now, I have drawn a scatter plot between area on x-axis and sale price on y-axis. Now, you people are finding one. Now, this is positive. Can you please respond, Amma? Can you please respond? Is it positive relationship or is it negative relationship? Today I discussed about these points. Please respond to me. Now, whenever you are getting the value like this, this is called as positive relationship. Now, what is the meaning of positive relationship? When the, please look at here. When the, what is x-axis we have? Look at here. When the area is increasing, look at here. When area increases, sale price also increases. Okay. This is called as positive correlation. Okay, for all of you. Now, when the area is decreasing, sale price also decreases. It is called as a positive correlation. Now, when you find out either positive correlation or negative correlation, then you are eligible to apply regression analysis. See here what I am doing. Now, first of all, I will be importing linear regression from a library called scalar.linear underscore model. Okay, for all of you, ma? Okay, now I need to divide the data into input X and output Y. Okay. So for that purpose, what I'm doing, area may be on x-axis and price will be on y-axis. See here what I'm doing, data frame dot LOC. Now what is the meaning of this one? Colon comma 0 colon 1. Meaning is before comma which represents about rows. What is the meaning of that? All 1459 rows I will be taking as rows and the 0th column will be stored in X and first column will be stored in Y. Is it okay for all of you? Here. Now, I have divided my data into input X and output Y. Input is treated as area and output is treated as Y. Is it okay for all of you? And what is my first statement? I need to create an object of linear regression. Okay, this is the first step we should do. Once we create an object of the linear regression object, then we should call fit function. Okay, we should call fit function. Okay, now look at here. Let me create an object and call the model. My model name is model 2. Now, I told you now, if you want to calculate R square value must be 0 to 1. This R square value can also be calculated by using a function called score. Score is a function where I will be supplying input data X and output data Y. See here, what will be my R square value? Now the R square value for this example is 0.50. Now we can treat this as average model. Kindly respond, Amma. Now, see here, I will be printing intercept value and coefficient values. I will be creating a model. This is what we have to do, Amma. Here, please look at here. Now, model dot intercept as coefficient. This is called as beta naught and this is called as beta 1. And I will be asking my machine if I want to buy a house with 1,715 square feet, what will be the price I should pay? Is it okay? Now, please look at here. I will be calculating prediction values for the 1,715 square feet. Okay, I know the beta naught value, I know the beta 1 value. Now, the answer is, look at here, I need to spend 20,000. This much money I should pay. Okay, for all of you? Now, I will wait here for 1 minute. Sir, can R square value be found as, no, it's not greater than 1, not greater than 1. Okay, Ahmed Khan. R square value must be 0 to 1. Okay, Nama? If R square value is 0, that is called as poor model. If R square value is 1, that can be treated as good model. Okay? Can you respond, Nama? Now, here what I'm doing, I'm predicting the value. See here, Nama? Yes. Now, I will be calculating metrics. Look at here, please. Yes, look at here, please. I'm calculating RMSE. I'm calculating R square value also. Now, I wanted to test the data. Please, I want, listen carefully, please. I created a model now. I wanted to test it. For that purpose, I'm taking unknown house price on another CSV file. Look at here, Amma. Please look at here. Now, I have taken a price called 1,715 as unknown data. Look at here. I have taken area as 1,015. Now, I want to ask my machine to predict the value. See here, I'm reading the data from unknown.csv. See here, now my unknown value is 1,015. For what is for 1,715 square feet of input data, what is my output variable? I need to spend this much money. Is it okay for all of you? Now, I have created a model. Now, I have tested a model with unknown data. This is a very simple case study to discuss about simple linear regression. Now, I will wait here for a few minutes. Any questions, if you ask me, I will be happy to respond to you, Amma. Okay, na? Later, we'll go for multiple linear regression. Okay. Now, any questions in the code, you please ask me. I will be happy to respond to you. Okay. Anyone? Please kindly respond, Amma. Any questions? Can you give? Yes, I will give. See here. Here I will give. Yeah. How much it is, Amma? 1,540. Now, let me run this model once again. Run R. See here. This much money you should pay. Okay, Nama? Amulya? Amulya Sai. Yeah. Now, with your permission, till now we have discussed with the concept of simple linear regression. Now, in the next case study, shall I take multiple linear regression, a beautiful case study from Kaggle? Now, with your permission, can I go? Yes. Now, first of all, before going to the data, you should see the database. Okay. Now, I'll show you the database in a few minutes. Look at here, please. Now, this is beautiful case study. Next case study is very, very important case study. Okay. Now, everyone listen carefully. Now, I will be taking another case study called advertisement case study. Everyone, please listen carefully about few minutes about the data set. Okay. Now, whenever you look at this database, you people are finding three input features. One is radio, I will call it as X1. Another one, sorry, one is TV. Next one is radio, X2, and newspaper, X3. So I have three input features, X1, X2, X3. And my target variable is sales. Can you respond, Amma? Now, can I call this as multiple linear regression? Multiple linear regression. Is it okay for all of you? Now, what I have to do, I need to map X1, X2, X3 with target variable sales. Okay. Now, when I have more than two or more than input features, then what is my equation? Y cap is equal to beta naught plus beta 1 TV plus beta 2 radio plus beta 3 newspaper. Are you getting me? Now I need to calculate beta 1, beta 2, and beta 3 and beta naught. These four are called as coefficients. Okay. Now I will call this model as a multiple linear regression. Now we need to study as a data science student. You need to study how TV affecting sales, how radio affecting sales, how newspaper affecting sales. Is it okay for all of you? Everyone understood the problem to be implemented? Problem to be implemented. Can you respond, Amma? Or combination of these three, how it is related to sales. I will be discussing beautiful analysis. Now, in the internship application also, we will be giving 3 case studies. Now, as a student, you can take up any problem and you can submit in 2 days. Okay. Now, this entire thing will be done in this week end. Okay. Now, with your permission, can I go for implementation of this case study? And you respond, Amma? Now, my question is, now I have 3 input features, X1, X2, X3. How many models I need to create? This is the point of discussion. Most of the students are failing that if I take X1, X2, X3, I will be creating model 1. Okay, na? Now, as a data science student, what you have to do? Now, with input X1 target variable Y, this is model 2. With X2 target variable Y, this is model 3. With X3 target variable Y, now we are creating model 4. Now, the combination of X1, X2, you need to have target variable. This is M5. X1, X3 with the target variable Y, model M6. X2, X3 with target variable M7. So, as a data science student, what you should do? You need to create 7 models. Okay. Out of 7 models, which model is giving highest, best value? Now, you have to use metrics like RMSE and R-square values. By using these 2 metrics, you have to identify the best model. That best model will be given to the deployment. Okay. As a data science student, you need to create that many number of models. So, with your permission, can I start, Andy? Can I go forward? Yeah. Now, let me go to the study. I hope till now everyone is okay. Now, let me go for how this advertisement data set will be implemented using multiple linear regression. Okay, now? Let me clear the screen. Yes. Now, first of all, whenever you are implementing any case study, the first job is you need to import the libraries like pandas for data analysis, NumPy for mathematical applications, and matplotlib and cbar. Both are used for data visualization. Then, first of all, I am reading the data and put it in a variable called as data. Now, data is called as data frame. Okay. Now, it means first 5 records I'm printing. Is it okay for all of you, ma? Then, now I will be checking, see here, for missing values. Do I have any missing data or not? Yesterday I discussed about a function called isNull.sum. Okay. I don't have any missing values. Okay, for all of you. Now, while doing regression analysis, you must be careful. You must find out the relationship between every variable with target variable. So I will be drawing scatter plot between TV and sales, and another scatter plot with radio and sales, and a newspaper with sales. That means we are studying the relationship between every input feature with the target variable. Is it okay for all of you? Are you getting me? Now, we are taking the figure size as 12, 6. Means 12 inches width. I'm going to create a figure 12 inches width and 6 inches height. Okay, for all of you. Now, I will be creating 1, 3, 1. What is the meaning of 1, 3, 1? I will be taking one row. I will be taking 3 figures. Okay. The first figure will be TV with sales. Second figure will be the relationship between radio and sales. Third one is newspaper and sales. With your permission, can I go forward to implement this? Yes. Look at here. I will show the figure. Please listen carefully and tell me. Now, what is your observation from this? Can anyone tell me? Yes. Now, the relationship between TV with sales is positive. Relationship between radio with sales is positive. Relationship between newspaper and sales is positive. Yes. Now we are officially applying regression analysis. Look at here, please, carefully, Emma. Now, the scatter plot shows that TV versus sales showing strong positive relationship. Okay. And radio and sales is also showing positive relationship among them. And third one is also newspaper is also showing positive, but it is showing a little bit weak relationship. Okay. Now, for every point, you should write this kind of analysis, Amma. Okay. As a data analyst or data scientist, whatever the analysis you are doing, you have to note down this point. Now, what is the next step here? I will be taking input data X and output data Y. Now, what I'm doing now? Now, whenever you are taking more than one input variable, you must use double square brackets. So, in TV, radio, newspapers, I am taking it as X. And see here. TV, radio, newspapers, I'm taking it as X. Now, whatever the data we have, this data is a scattered data. So, I need to do normalization. Yesterday, I told you normalization. That I discussed about, you can use min-max scalar or you can use standard scalar. Now, first of all, import the library, then create an object of the class, then call bit_transformation function. See here what is happening? See here. So earlier my data is represented as 30.1, 37.8, and 69. Now the data has been changed to this one. Okay, for all of you, then. Now let us take output variable Y. Now, I will be dividing my data into, now, everyone please look at carefully. Now, in order to train the data, we need to divide the data into 4 parts. Now, this is called as X and this is called as Y. Generally, 70% of the data will be used for training and 30% of the data will be used for testing. Okay. Now, look at here, please, Amma. This part is called as X train. And this part is called as Y train, and this part is called as X test, and this part is called as Y test. Okay, Nama? Now by using a function called train_test_split, X is the input data and Y is the output data, and I will be dividing my data into 80% is training and 20% is testing. It is up to you. 70, 30, 80, 20, 90, 10. It depends upon the availability of the data. Is it okay for all of you? Now, let us divide the data into 4 parts. Okay. Once you divide the data into 4 parts, now I will be creating an object of linear regression. Okay, for all of you, ma? Now, any questions till now? Now, look at here. I am training the data. Now, to train the data, I will be using X train variable and Y train variables. Look at here. Yes, the machine got trained. Now, once machine got trained, then we should predict the data. Now, I will be sending X test data. Now, the model has predicted data. This is called as Y prediction. Okay, for all of you. Now, once we have the Y prediction value, we have to calculate 2 things. First one is mean squared error. See here, mean squared error. Now, in order to calculate mean squared error, you have a library called sklearn.metrics and import mean square and r square values. Now, I am going to forward y test value. Y test value has not been given for training, has not been given for testing. This data is called as original data or ground truth data, which will be used with Y protection. See here, my RMS value, mean square error is 3.17 and R square value is 0.89. Now, can I say that this model is good model, Amma? Please kindly respond. Okay. Now, this value is nearly 1. So, can I say that it is not average, Amma? You people are doing same thing, Amma. You people are doing same mistakes. I told you, na, if the value is nearly 1, 89 is not nearly 1. 89% is not nearly 1. Yes. You have a test box. You can't type whatever you want. Please understand and tell me. Okay, Nama? 89% it's a good one, Amma. You can't get nearly 100 every time. Okay. I'm not discussing about true, Amma. Never discuss Dhanlakshmi. Same point you are repeating once again. I'm not saying true. I said that if the value is nearly 1, that is good model. I did not discuss about true or false. Okay. Dhanlakshmi. Performance of algorithms cannot be represented as true or false. It will be in terms of percentages. Okay, for all of you. Can I go forward, Amma? Yes. Now, how to check the model performance? Now, look at here, please. How to check the model performance? Now, see here, the MSE value is the MSE measures average square difference between actual data and predicted data. Now, the lower MSE indicates the better model. Now, it is not nearly 0, but it is very nearly 0. So, the lower MSE indicates better performance. For example, here, maybe earlier, whenever I run, I got 2.8. Now, I got 3.1. MSE 2.8 or 3.17, the model performance is average. It's just average. Okay. But if you get nearly 0, I will call that as better model. Now let us study R square value. See here, the R square value measures the portion of variance in the target variable. Okay. Now it ranges from 0 to 1. 0 indicates best model. So if the R square value is 0.89, I can say that 89% variability in the sales. So can I say that good model, Amma? With TV, radio, and newspapers. Can you please respond to me? Absolutely, yes. Good model, Amma. Yes, it is a good model. Now, here, I will be drawing a scatter plot. Now, I will be drawing a scatter plot between Y test values and Y prediction values. See here what is happening. See here what is happening. All my points, most of the data points will be on the straight line. Still, you have some errors. Okay, Nama? Okay, na? Now, here, beta naught is equal to 14.04, that is called as intercept, and beta 1 is 3.83, that is TV, and radio is 2.8, and newspaper is 0.05. So, the most important feature is TV, then newspaper. Radio is impacting very less. Okay, Nama? From these, beta 1, beta 2, beta 3, we need to go for some analysis. What are the key insights here? Now, see here. The coefficient value 2, see here. What is the coefficient value? 3.83. This is for TV. The coefficient value TV advertisement is largest value, indicating that TV is strongly positive impact. Is it okay? Whatever the ML model you are writing, you have to write the insights. See here. TV has strong positive impact on sales. Now, increasing TV advertisements. Now, if I spend more money on TV, I will get good returns. Is it okay for all of you? After completion of every analysis, every case study, you have to write this analysis. Okay for all of you? Now, let us study about radio. The coefficient of radio is 2.80. See, it is also significant, but smaller than TV. Okay, now? Third one, newspapers. It is worst case. See here. The coefficient value newspaper advertisement is very small. So it indicates that almost no impact on sales. So if I ask you one question, out of 3 parameters, which parameter is strongly depends upon sales? Can anyone respond, Amma? Yes, TV. That's it. Now, the intercept value is 14.04. How much intercept value we have here? 14.04. Can you respond? Yes. Which represents the baseline sales. When no advertisement is done, it is expected sales is absent. This is what you have to do. Okay. You have to write the case studies and you must write this kind of analysis, the impact of each and everything. With your permission, can I go forward, Amma? Now, look at here. I will be creating all other models. See here. I will be creating so many other models. See here. Now, let me continue. Yes. Now, here what is happening? I will be taking various kinds of models. See, I will be taking various kinds of models. How each and every models are effective. See here. Now, if I take these data, see here, everyone, what is happening? Now, instead of TV, radio, newspapers, now I am taking, see here, I am taking, if you observe carefully, now my mean square error has been came to 0.16. How it happened? And R square value has been nearly 0.99. You got it? Yes, it is nearly 1. Now, let us study about how we have done this. Look at here carefully. Okay. Now, I have done some optimization. Okay. Now, what I have done here, instead of taking TV, radio, newspapers, I have also taken log of the data. Okay. Now, whenever you do log transformation, what is happening? My positive skewness values has been converted into normal curves. Now, see here, my impact of the data. See here, my impact of the data. If I take log of TV, impact is increasing. Log of radio, log of newspaper. Now, I have printed all the values. Now, if you take another regression analysis called lasso regression analysis, what is the basic purpose of lasso regression analysis? Now, I wanted to implement a small case study. And now, with your permission, can I discuss about lasso regression analysis and ridge regression analysis with a small case study? Please kindly respond to me. Whenever there are some cases, please. There are some real-time cases where I have taken Melbourne house price data set. It is the data set directly which has been taken from Kaggle. Now, if I apply linear regression, what is happening? See, observe here. See here, what is happening? If I apply linear regression, what is the result it is giving? See here. See here, R square value is, see here, what is happening? On the training data, it is giving 68.8. But with the test data, it is giving 0.13. So, on the training data, the model is giving good results. On the test data, it is giving poor results. This is called as overfit. Okay. This is very, very important for interview purpose for everyone. So, to overcome this, what is happening? What is overfit? Means when the model is on the training data, if it is giving good results, on the test data, it is giving poor results. Then you should apply another two regression analysis techniques called lasso regression and ridge regression. Now, I will be applying this regression analysis. Please look at here, where we are going to change the lambda value. Okay, I'm not teaching, but look at here, what is happening. See here, on the test data, the percentage is 0.66. On the training data, 67. Is it okay? Whenever you are having overfit, you should go for lasso regression, or you can also go for ridge regression. See here. Now we can see that lasso and ridge regressions can benefit when we have model is overfit. Okay. Now these results shows that whenever we are having whenever we are having overfit condition with the results, you should apply two new techniques called lasso mechanism as well as ridge mechanism. Is it okay for all of you, ma? Now this is till now whatever I have discussed is called as linear regression. Now with your permission, can I spend few minutes on non-linear regression? You please respond to me. Earlier, we discussed that linear regression has been linear regression and non-linear regression. Is it okay? Now, till now, whatever techniques I have applied, like linear regression or lasso or ridge, these three are part of linear regression. But when the data is not following line equation plus as y equal to mx plus c, now you have to apply non-linear regression. Here I will be using polynomial regression. Is it okay for all of you? Now, when to use polynomial regression? Can anyone respond, Amma? Now, yes, can anyone respond? When to use polynomial regression? Okay. When my data is not following line equation, the line equation equal to y cap equal to beta naught plus beta 1 x. Now, when I'm not following line equation like this, either let me draw. You have to have either positive relationship or you should have negative relationship. Then only we'll apply regression analysis. Yes, you have to go for non-linear regression. One such kind of non-linear regression is, I think it is not there here. Let me take 1 minute to take the non-linear regression example, Amma. Please give me 1 minute. Give me 1 minute, please. Just 1 minute, Amma. One minute. Let me take non-linear regression. Yes, polynomial regression, and let me explain. Session number 9. Yes, let me go now. Now, if you look at this data carefully, here, why I am unable to apply linear regression? Here, let me go down. Everyone, please look at here. Here, now, can anyone tell me whether the data is linear data or non-linear data? Tell me. All the people, can you please tell me what kind of data it is? It is not linear, Amma. See here, you people are having curvature data. So even though I had drawn a line, none of the points are going through the. So this is non-linear. When the data is non-linear in the nature, you cannot apply linear regression. Are you getting me? Then you should go for polynomial regression. See here, I'm to discuss about polynomial regression. How the polynomial regression will be implemented. See here, you create a linear regression object. Yes. Then you pass this object. See here, create a polynomial features and degree is to and fit underscore transformation. See here what is happening. Now after conversion of polynomial regression, my values are here. When I draw a line, most of the points are going over the point. So this is called as polynomial regression. Okay. Sir, will you provide notes? Yes, at the end of the day. Okay, please. This is what is today's topic. Yeah, I have covered each and everything, Amma. Yeah. Now, if you 5 minutes, I will wait for you. If you have any questions, I will be happy to respond to you. I have discussed about the mathematics fundamentals about. I have discussed about mathematical fundamentals about linear regression. Then I went to discuss about simple linear regression mathematics and case studies. Yeah. Any questions, Sama? Sir? Notes will be provided at the end of the day. The people who are regularly attending will share the data. Yes. How is the session, Amma, regarding regression analysis? Did not run non-linear regression. You want to see the running? Yes, see here. See here. I will share the screen. Nothing is there, Amma. Just run all cells. That's it. Look at here. Is it okay? I have already ran before the programs. Is it okay, Nama? Yes. Sir, please explain today's first topic. Pravalika, what is the first topic? Yes, I will share the screen, Amma. Please look at here. I will share the screen. Can you tell me which is the thing you are asking? Are you asking this one? ఏమడుగుతున్నారమ్మా? Please let me view it. Yes, I hope you people are asking this. This mathematical model, Amma? Prahalika, are you asking this one? Pravalika, please ask me. Please look at here. Pravalika. Yes. Now, this is mathematical model, Amma. This is a mathematical model for now. This is input data X, output data Y. So I need to calculate y cap is equal to beta naught plus beta 1 AX. Now I need to calculate beta naught and beta 1 kada. I given formulas. Beta 1 is equal to summation of xi minus x bar multiply yi minus y bar divided by summation of xi minus x bar whole square. Now, to calculate these values, first of all, I have calculated x bar value. I have calculated y bar value. Okay, Nama? Subtract every value minus x bar. See here, 95 minus 78, 85 minus 78. Is it okay? Then yi minus y bar. Then if I multiply these two values, I'll get this one, summation of 470. So 470 divided by xi minus x bar whole square 730. So 470 divided by 730, beta 1 is 0.64. Okay, Nama? Yes. Ravalika, yes. Yeah. Any more questions from anyone? Yeah. Any more questions, Sama, from anyone? Yeah. I hope if you don't have any questions, I will be closing the session. Thank you very much for attending. Thank you very much. Let me